When you think of a drone, you probably picture a little quadcopter, right? Something buzzing around the park. But what about the really high-performance unmanned aerial vehicles, the UAVs, that can fly for days, carry serious equipment, and run critical missions all over the world? Well, what's under their hood is a completely different story. So let's dive in and explore the powerful engines that turn these drones from hobby toys into indispensable, high-power tools. To really get why these high-power engines are so important, we first have to talk about the biggest problem facing most drones you see today, the battery. You see, for all their convenience, batteries have some serious limitations. They create a kind of ceiling on what a UAV can actually do.
I mean, take a look at this. It's a design we all know, and it's brilliant for what it does. It's quiet, it's pretty easy to fly, and it's fantastic for getting some cool aerial photos. But its biggest weakness? It's that power source. After maybe 20, 30 minutes, it's begging to be plugged in again, which it brings up a really important question.
That is the million-dollar question, isn't it? The problem really comes down to what we call the battery bottleneck. Batteries just don't pack enough punch for their weight. That means short flight times, it means they can't carry heavy stuff like advanced sensors or critical cargo, and of course, their range is super limited. So how do we get past these limits?
Well, the answer is to move away from batteries and embrace something a little more traditional, but way, way more powerful, the internal combustion engine. This is where drones really level up. They unlock abilities that they're completely impossible for their battery-powered cousins. And when you look at it side by side like this, the difference is just staggering. With batteries, you're stuck waiting for hours to recharge just to get another few minutes in the air. With an engine, you can refuel in minutes and fly for hours, sometimes even for days. You can carry payloads that weigh hundreds of kilograms. Your whole operational footprint just explodes. And when we say extended range, we really mean it. We're talking about missions that can cover over 1,000 kilometers on a single tank of fuel. This isn't just a small step up, it is a total game changer. It opens the door to completely new ways of using UAV technology.
So while we're going to focus in on the internal combustion engine, it's really just one member of a bigger family of propulsion systems. So let's do a quick tour of the main players in the UAV world, just so we can see where everything fits.
Okay, first up, the piston. This is where all the action starts. It moves up inside a cylinder, squishing a mix of air and fuel. Then a tiny controlled explosion forces it violently back down. That powerful, straight, up and down motion, that's the raw energy we need to capture. So how do we make it useful?
Well, that is the job of the crankshaft. The best way to think about it is like the pedals on a bicycle. Your legs push up and down, right? But the crankshaft turns that into a spinning motion that drives the wheel forward. In our drone, that spinning force is what's going to turn the propeller. And finally, we have the camshaft. So if the piston is the muscle and the crankshaft is what gets things moving, then the camshaft is the brain. It has these carefully shaped bumps called lobes, and they push open valves at just the right second, letting the engine breathe in the air-fuel mix and then breathe out the exhaust. It is all about perfect timing. Now, inside the world of IC engines, you've basically got two main flavors: petrol or gasoline and diesel. And as you can see here, they get to the same result in totally different ways. A petrol engine uses a spark plug to light the fuel. A diesel engine, on the other hand, just squeezes the air so hard that it gets hot enough to ignite the fuel all by itself. That difference in how they create the bang is really what sets them apart.
Okay, so we've seen the mechanics. Now let's connect all this tech to its real-world impact. What does all this power and endurance actually let us do? This is where the theory hits the road, from huge farms to strategic front lines. And the applications are just incredibly diverse. For the military, we're talking about long-range surveillance missions that can last for more than 24 hours straight, continuous border patrol, precision strike capabilities that keep personnel out of harm's way. And in the commercial world, it's about monitoring massive farms, inspecting hundreds of kilometers of pipelines, or even flying heavy cargo out to remote places. Engineers are always pushing the limits to create systems that are even more powerful, more efficient, and, smarter. It's pretty clear the future is hybrid. The next generation of UAVs isn't going to be just one or the other. They'll combine the best of both worlds, using an internal combustion engine for that long-haul cruise, and then switching to a quiet electric motor for takeoffs, landings, or silent observation. It's about getting the best of both endurance and efficiency, all in one package. And that brings us to our final thought.
As the brains of these drones, their autonomous systems, get smarter and smarter, the hearts, their engines, are going to have to evolve right alongside them. How do we make these engines reliable enough for missions where there's no human pilot to intervene at all? That, right there, is the next great challenge in the world of UAV propulsion.